Hello everyone! In this video, I'm going to break down the ROC curve, a powerful tool for evaluating the performance of binary classifiers in machine learning. The ROC curve stands for Receiver Operating Characteristic Curve. It's a graphical plot that illustrates the diagnostic ability of a binary classifier system as its discrimination threshold is varied. On the x-axis, we have the false positive rate, or FPR. On the y-axis, we have the true positive rate, or TPR. These two metrics help us understand how well our model distinguishes between the two classes. A diagonal line on the plot represents a random classifier, one that makes predictions by chance. Any model that performs along this line isn't really learning anything useful. The ROC curve itself shows how the true positive rate and false positive rate change as we adjust the classification threshold. Each point on this curve corresponds to a different threshold for classifying a positive result. The closer the curve follows the left-hand border and then the top border of the ROC space, the better the model's performance. The area under the ROC curve, or AUC, is a single number summary of the model's ability to discriminate between positive and negative classes. The higher the AUC, the better the model is at distinguishing between the classes. The top left corner of the plot represents a perfect classifier. Here, the false positive rate is 0, and the true positive rate is 1. In other words, the model makes no mistakes. It finds all positives and never mislabels a negative as positive. This is the ideal scenario, but in practice, it's rarely achievable. To sum up, the ROC curve helps us visualize and compare the performance of classifiers. A curve closer to the top left corner and a higher AUC indicate a better model. Thanks for watching. If you found this explanation helpful, don't forget to like, subscribe, and leave your questions in the comments below. See you in the next video.